Hello everyone, my name is Larisa Mocanu and I'm a PhD student at the University of Cassino and Southern Lazio. The work presented today is a collaboration between us from the University of Cassino, the Norwegian University NTNU, and the Research Center SIRA from Capua. And it's focused on the effects of recycling on defects and microstructure in titanium powder particles and in samples produced with the electron beam melting process. So, first of all, a brief introduction. The electron beam melting process starts with a metal powder which is previously atomized according to one of the several existing methods. And then, after a layer-by-layer manufacturing cycle, we will obtain our components and, of course, a certain amount of waste powder. In order to improve the process efficiency and to lower the production cost, it is possible to reuse this waste powder in the next manufacturing cycle. So, starting with this waste powder, this waste powder is firstly sieved in order to eliminate any damaged particles, broken particles, and so on. And then it is also possible to mix this sieved powder with other virgin powder in order to lower the oxygen content. And then, starting with this mixed powder, another layer-by-layer manufacturing cycle will begin, at the end of which we will obtain other components, this time made with recycled powder, and other waste powder. So the aim of this work is to understand the differences between these components made with virgin powder and these components made with recycled powder. And of course, also the differences between this waste powder and the virgin one. So, more in detail, in this work we analyzed two batches of titanium powder particles, grade 5. The first one is a batch of virgin powder produced with a plasma atomization process, while the second batch is a powder recycled more than 100 times. And then, manufactured with these two batches of titanium powder particles, we have 3 samples for each batch, so a total of 6 samples, in order to carry out the microstructure analysis on the two batches of titanium powder particles. And then, regarding the samples, we perform both the microstructural and the internal defects. So here there are some results from our previous work. We analyzed the external situation and the morphology of the titanium powder particles, and we saw that the virgin powder is characterized by a higher amount of these tiny particles, which are called satellites, while the recycled powder is characterized by a lower amount of these satellites. And this is mainly due to the preheating inside the ABM chamber. The less amount of these satellites increase the flowability, but at the same time, other damaged particles appear, such as these elongated particles, broken particles, non-spherical particles, and so on. And also, the oxygen content within the recycled powder is increased, and this could be detrimental for specific fields, such as the aerospace field, where the amount of oxygen is. Then we also investigated the internal situation and in particular the internal porosity, and we performed some image quantitative analysis in order to obtain a quantitative result, and we saw that the recycled powder is characterized by a lower amount of these tiny particles, tiny porosity, and this is due to the preheating inside the ABM chamber. Then in this work we analyzed the microstructure, and we saw that the virgin powder is characterized by a martensitic microstructure, and this is due to the fast cooling rate during the atomization process. Regarding the recycled powder, we saw that most of them exhibit a quartz-anode microstructure, as can be seen here, and this is due to the lower cooling rate during the production cycle. But not all the particles exhibit the same quartz-anode microstructure, as can be seen from these particles highlighted in green. This is more similar to the virgin powders, and this is due to the fact that each powder particles experienced a unique thermal history, and this is true because some particles are closer to the melt pool, while other particles are far from the melt. And something interesting we found is this alpha case, which is a layer rich in oxygen around the powder particles. This is true only in the recycled powder. And this alpha case is also characterized by a higher hardness. But in order to properly investigate this topic, some other evaluations, such as the nano hardness test, is necessary. Here we have the sample preparation. We started with these 6 bars and we sectioned them in order to evaluate the situation in the upper part of the component and in the lower part of the component, because we wanted also to see if there are any influence regarding the building plate. And then we simply performed metallographic preparation in order to obtain this embedded resin sample, and then through the etching process we investigated. So here the results regarding the defects. We saw that both the kind of components are characterized by the typical defects in the electron beam melting process, which are mainly due to the process parameters, while the only defects which are due to the recycling process are all of this tiny porosity, which are due to the gas entrapped in the powders itself. Here a more detailed view regarding the internal defects. We also performed an image quantitative analysis in order to obtain the percentage of defects, and we saw that the sample manufactured with virgin powder is characterized by a higher amount of these defects. So then regarding the microstructure, we saw that there is no particular differences between the two kinds of components and between the two longitudinal area and cross-sectional area. The microstructure was a basket wave 1, which is a typical microstructure in the titanium component. Something interesting we saw is this prior beta grains, which tend to follow the building direction. This is true only in the center of the specimen, as can be seen here, while closer to the edges, so in the surface, these prior beta grains have no specific direction. So in the conclusion, in this work, we analyzed the microstructure and the microstructure and the internal defects in both powder particles and in the components made with the electron beam melting process. And we saw that the virgin powder is mainly characterized by a martensitic microstructure, which is due to the fast cooling rate during the atomization process, while the recycled powder is mainly characterized by a quartz-ended microstructure, while the martensitic is present in a smaller quantity. Then we also saw that the recycled powder is characterized by this oxygen-rich layer, which is known as the alpha case. But in this case, other evaluation are necessary in order to fully understand this topic. Then regarding the components, we saw that both the kind of components are characterized by the typical defects in the electron beam melting process, and they are mainly due to the process parameters, while the only defects which are due to the powder recycling are the tiny porosity, which are due to the gas entrapped in the powders itself. Then regarding the microstructure, we saw no particular differences between the two kinds of components and between the two longitudinal and cross-sectional areas. And also in the upper part and in the lower part, the microstructure was mainly the same, which is a basket wave microstructure, which is a typical microstructure in the titanium components. And finally, we saw that these prior beta grains tend to follow the building direction. This was true only in the center of the specimen, while close to the edges, so in the surface, these prior beta grains exhibit no specific direction. Thank you for your attention.